Now we want to do problem 18 from section 19 homework. For this problem, we have a double integral, and we're trying to integrate cosine of x cubed dx dy. But what we should realize is that it's hard to integrate cosine of x cubed with respect to x. If we do a u substitution, u equals x cubed, we would need du to be here, the 3x squared dx, and it's not, so it's not going to be a simple u substitution. So what we want to do is to replace dx dy with dy dx, change the order of integration. Or we could say switch the order of integration. So we want to switch the order of integration, make this dy dx. To do that, we want to see what region is described by these limits of integration in this double integral. We have y going from 0 to 1. For each fixed y between 0 and 1, we want x to go from the square root of y to 1. So let me show you the picture and explain where it came from. So again, y is going from 0 to 1. And then I want to imagine drawing a horizontal line and having x go from x equals the square root of y to x equals 1. You probably recognize the x equals 1 here, going straight up. This is x equals the square root of y, because x equals the square root of y when I square both sides is the same thing as y equals x squared. So that's just giving me this parabola y equals x squared. And you can see they intersect at 1, 1. Well, let me put the x equals 1 in here. So x has to be 1, and then y will be 1. So this is 1, 1. And they also go through, this curve also goes through the origin here. So we have x then going between 0 and 1, and y going from 0, or down here, to y equals x squared here in this region. But notice I knew which part to shade in, because when y goes from 0 to 1 and I take a horizontal line, this is telling me that I want to go from the square root of y to x equals 1. So I want to go from here to here. So that's telling me this part needs to be shaded. Setting up the limits of integration, again, I have dx on the outside now because I'm switching the order of integration, and x is going from 0 to 1. For each x between 0 and 1, I want to draw a vertical line and think of what's happening to y. Y is going to go from the bottom here, y equals 0, to y equals x squared up here. So it's going from y equals 0 to y equals x squared, and that's why I have 0 to x squared. I still have the same function I'm trying to integrate, but I have successfully now switched the order of integration, and I can see this is not going to be bad to integrate with respect to y because this is just a constant. So let me do the integration now. Again, I'm just going to cosine x cubed, the constant, times y when I integrate. Y is evaluated from 0 to x squared, so I'm going to have x squared minus 0 here. So it's just going to be x squared times cosine of x cubed. I want to integrate this with respect to x. We want to do that, well, it looks like it's a u substitution. U equals x cubed now. Du is 3x squared dx. Dividing by 3, we have x squared dx is 1/3 du. So I can replace this x squared dx with 1/3 du, and this x cubed with u. Doing the indefinite integral, we have the integral of cosine of x cubed x squared. I'm going to replace the x squared dx again with 1/3 du, and the x cubed with u. Integrating cosine of u, that's just sine u. We had this over 3, and then plus a constant. But this tells us that an antiderivative for cosine x cubed x squared is sine of x cubed over 3. So I can evaluate this integral here by using this antiderivative for cosine x cubed x squared, sine of x cubed over 3, and evaluate from x equals 0 to 1. At 0, sine is 0, so it's just sine of 1 over 3. And that is the value then of this double integral we started with. It's sine of 1 over 3, and we did that by, again, switching the order of integration. Now let's look at problem 28. We want to calculate this double integral. And again, it looks like it's hard to integrate this with dx. Not impossible. You could try a trig substitution here, but it would be a lot easier to integrate with respect to y, and that would just give me a constant then that I'm integrating with respect to y. So I'm going to switch the order of integration. What is this region we're integrating over? Y is going from 0 to 2. For each fixed y, x is going from y over 2 to 1. X equals y over 2 is the same as y equals 2x. That's just a line with slope 2 going through the origin. So the picture looks like this. For each fixed y between 0 and 2, x is going to go from this line. That line is y equals 2x. Again, x equals y over 2 and y equals 2x is the same thing. It's going from the line y equals 2x to the line where x equals 1 here. So x is going from here to here. Going from y equals 2x to x equals 1. Or from x equals y over 2 to x equals 1. So you're just getting this triangle here. We want to switch the order of integration, make this dy dx, and we want to look at this triangle to figure out what those limits of integrations are. We can see because when x equals 1, y is 2, that it goes through this point 1, 2 here, and also goes through the origin, this line here. So x is going to go from 0 to 1, and for each fixed x, y is going to go from 0 to 2x. So when I set up this integral, x again is going from 0 to 1. For each fixed x, we draw a vertical line, and y goes from 0 to 2x. So that gives me the limit 0 to 2x for y. So I want to solve this integral now, where now this is easy to integrate with respect to y because it's just a constant. So I'm just going to get square root of x squared plus 1 times y. And I want to evaluate that from y equals 0 to y equals 2x. So this will get replaced with 2x minus 0, or 2x. I've rewritten square root of x squared plus 1 as x squared plus 1 to the 1/2. And again, when I evaluate y from 0 to 2x, I got 2x. So I can think now what would happen if I did a substitution u equals x squared plus 1. I would have u to the 1/2 here, and 2x dx is just du. If u equals x squared plus 1, du is 2x dx. So this is just the integral of u to the 1/2 du. And you'll get u to the 3/2 over 3/2. So when I evaluate this, I have u to the 3/2, x squared plus 1 to the 3/2, over 3/2, and 3/2 in the denominator is the same thing as multiplying by 2/3. So I have 2/3 times x squared plus 1 to the 3/2. I want to evaluate this from x equals 0 to 1. So when I plug in 1, I'm going to get 2 to the 3/2. Again, don't forget to plug in 0. You'll have 1 to the 3/2. So this evaluated from 0 to 1 is going to be 2 to the 3/2 minus 1. So the final answer will be 2/3, 2 to the 3/2 minus